Today we are going to talk about functions. The function command helps us represent behaviors. The two most important behaviors that we're going to see are the exponential behavior and the normal behavior. This represents, for example, variables such as the time between arrivals and the attention time. In the function command, we need a name of a function. Then we must indicate that it is a function and it has two parameters. The first parameter is the function argument. It's always going to be Rn, and it stands for random. The B parameter, it's the type of the function. It's going to be C for continuous, D for discrete, and then it's going to be followed by data pairs. These data pairs represent the behavior of the function. In the exponential case, we name this XPDIS for exponential distribution. Then we indicate that it's a function, random one. This means that for each pair of data, we are going to have one random variable. Continuous, C for continuous, and 24 because it is defined by 24 data pairs. When we are going to use the exponential distribution, we can use, for example, in a generate. First, we put the generate command, then the A parameter is going to be the average of the exponential distribution, in this case 100, then Fn for a function, the string character, and then the name. In this case, it's going to generate transactions every 100 time units with an exponential distribution behavior. In the case of the normal distribution, we name it as norm. We indicate that it's a function, random one, and continuous 25. C25 for 25 data pairs. In the case of the normal distribution, we need to define a variable. This variable helps us use the function. In the example that we're seeing, we define a variable named gnorm. We establish that it's a variable. You can put f variable as in the slide, or just variable without the f, and it would work just fine. Then we establish that it's a function fn, then the string character, the name of the function as norm, and the hashtag, the hash indicates the standard deviation, and the plus sign means the average. In this case, we have a variable named gnorm that behaves like a normal distribution with a standard deviation of 3 and an average of 15. And we use it. We don't use the normal distribution, but we use the variable that represents the behavior of the normal distribution. In this case, we are going to generate transactions behaving like the gnorm variable. The gnorm variable being a variable for a function named as norm with an average of 15 and a standard deviation of 3. And as norm is a normal function. With this in mind, we are going to go to the next example. This problem is going to be solved by you, and it says, on weekends, patients arrive at the emergency room of San Jose Hospital with an exponential distribution with mean of 5 minutes. There they wait for one of the two groups of 2 medical interns to be free. They have an attention time of a normal distribution with a mean of 8 and a variance of 4 minutes respectively. Patients who cannot be attended wait for 5 minutes, and if they cannot be attended again, they leave the hospital. Once they are attended, the personnel seeks placement for them in one of the 4 beds at the emergency room, where they will remain for 10 plus or minus 2 hours. If there is no bed available, the patient will be sent to look for a bed in the main hospital building that has 50 beds. There, they will be attended for about the same time as in the emergency room. This problem asks us to simulate the system for all Saturday and Sunday in the period from 8 to 12 p.m. on Friday. And we need to answer 3 questions. The first being, is it necessary to use hospital beds? Yes, no, and why? How many doctors are needed? And how will you distribute them? Now we're going to see this diagram that represents the problem. The patients arrive with an exponential time of 5 minutes. They see if the interns are unoccupied. If they are occupied, they wait 5 minutes. Then they pretend to seize them. And if they are still occupied, they leave. If they can attend it the first time or the second time, this yes or this yes, interns are on a storage of 2 and give an attention following a normal distribution with an average of 8 and a standard deviation of 2. Once they get the attention, they look for a bed. If there are beds available, they go to the beds on the emergency room, which is a storage of 4, and they spend 600 minutes with a standard deviation of 120, and they finish the process. If there are no beds available, they go to the main hospital building to look for a bed. If there aren't any bed, they return to the emergency room, and here begins a cycle until one bed is available, either in the emergency room or the main hospital building. When there is a bed available, they spend 10 hours with a standard deviation of 2. This is the representation of 10 hours and 2 in minutes. The hospital is going to be in a storage of 50. Once they finish the attention, they leave the hospital. This is the problem that you're going to need to solve from this session to the next. So we're going to finish the video right here.